Welcome to episode 6 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky. I then search for an astronomical object near those coordinates and spend a few minutes talking about that object and what makes it so scientifically important. So let's run the random number generator. And for this week, the random number generator has broken a light bulb. I'll need to replace that. The coordinates that came back from the generator are 11 hours, 22 minutes, 51.2 seconds right ascension, and plus 31 degrees, 49 minutes, 41 seconds declination. This points to a star located about 492 light-years or 151 parsecs away from Earth in the constellation Leo Minor called HD 98851. This is a rather complex and weird star, so it's going to take me a while to describe everything that's happening with it. First, HD 98851 is classified as a chemically peculiar star, which means that it has a weird combination of elements in its atmosphere as measured through spectroscopy. Based on the overall spectrum and brightness of the star, it would be classified as an F-type red giant or subgiant star. Red giant and subgiant stars are stars where the core has stopped fusing hydrogen into helium because it has filled up with helium, but where the fusion of hydrogen is still taking place in a shell around that core. The classification as F-type means that the star is slightly hotter than the Sun. However, F-type stars commonly have small amounts of calcium in their outer atmospheres, and the conditions are usually just right for the calcium to absorb light at wavelengths of 3934 and 3968 angstroms. This light absorption is not seen in the spectrum of HD 98851, so it is designated as chemically peculiar and given the spectral designation AM. Second, HD 98851 is a type of variable star called a delta Scuti variable, and it's named after the brightest star in this class. The variability in HD 98851 was only discovered back in the year 2000. In the last episode, I described a class of variable stars called RR Lyrae variables that are very old versions of the Sun that fuse helium into carbon in their cores, that fuse hydrogen into helium in shells around these cores, and that have unstable pulsating outer atmospheres. The atmospheres of delta Scuti variable stars exhibit the same type of instability, but these types of stars are younger and could include stars that are powered by fusing hydrogen into helium in their cores, like the Sun, or stars where the cores have just recently filled up with helium, like red giants, but where that helium is not being fused into carbon just yet. Even though the delta Scuti and RR Lyrae stars are very different ages and are powered by different fusion processes, both classes of stars apparently have the right conditions for the atmospheres to pulse periodically. At the beginning of the pulsation cycle, the outer atmosphere of one of these stars cools and contracts. This contraction causes an increase in the opacity of the stellar atmosphere, which then leads to an increase in temperature and brightness. This then causes the outer atmosphere to expand, but the expansion causes the gas to become less opaque and to cool, which then leads to the outer atmosphere contracting. This pulsation continues on for a very, very long time. One of the really surprising things about HD 98851 is that it is both an AM star and a delta Scuti variable star. It is normal to find stars with similar brightnesses and colors as HD 98851 that are either AM chemically peculiar or delta Scuti variables. but it's peculiar to find an AM chemically peculiar delta Scuti variable. The other peculiar thing about this star is that the variations in its brightness could be described as having two different pulsation cycles. One with a period of about 76 minutes, and one with a period of about 152 minutes. Now, if you're paying attention, that's a ratio of 1 to 2. A few other delta Scuti variables exhibit the same type of pulsation, and it's not entirely clear why, but one of the possibilities is that HD 98851 and similar delta Scuti variables are in binary star systems where some type of interaction with the companion star modulates the pulsation. If HD 98851 is in a binary star system, then this could be linked to why it is also an AM chemically peculiar star, as most other AM stars are also in binary star systems. So that was the peculiar, or extra peculiar star, HD 98851. The location on the Earth's surface that corresponds to the location of HD 98851 in the sky is a place slightly less than 1/3 of the way from Midway Island in the Pacific Ocean to Japan. This is also a place on the Earth's surface where you see the bend in the Hawaiian Emperor Seamount chain, which has implications for how hotspots move relative to major continental plates. But that discussion would be better for different podcasts, such as Emma's Random Geological Feature. If you liked this episode, the website for this podcast is www.randomastronomicalobject.com. If you didn't like this episode, the website is still www.randomastronomicalobject.com. You can visit the website to download episodes of the show, read information about the astronomical objects, view pictures of those objects, and send me random feedback. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Hendy at www.sasha-hendy.de, which is distributed by filmmusic.io under a CC 4.0 attribution license. The sound effects are from the Freesound Project at www.freesound.org. Thanks for listening.